So if you look back in history, there are essentially 4 key moments in the Earth observation sector itself. The first one ranging all the way back in around 1946, when we had the first image of our planet Earth captured through a camera attached to the V2 rocket. Secondly, during the Cold War, when US launched its own satellites to spy on Russia. Third, when that capability moved to the industry. Iconos being the first commercial satellite that went up and showed how there was business potential around it. And today we are going to see the fourth such moment where we'll have the first multi-sensor satellite that we at GalaxEye are going to launch, bringing in consistency to this whole imagery ecosystem that the world has never seen before.
The way to understand satellite imagery is you need 3 resolutions. Spatial resolution, which gives you how fine you can observe a particular point on Earth. The imagery could be as fine as 1 meter or 30 centimeters on Earth. It could be as coarser as 30 meters on Earth. The second resolution that we generally talk about is temporal resolution. Nothing but how often you can image the Earth. Right?
Third, radiometric resolution, which is what is the quality of your data, right?
Our eyes would see particular as one green, but the detector is able to capture even 15-20 different kind of greens.
And fourth, you have spectral resolution. While human eyes can only see particular wavelengths in the visible band, how much depth does this spectral information give you, right? Give you information beyond what you can see through human eyes.
On the basis of spectrum or the spectral signatures, you classify different sets of satellite imageries. Starts with the first, which is multispectral or optical. It is very similar to what human eyes observe. It gives you red, green, blue as colors to visualize and interpret.
Human eyes can't see through certain things, that's the same problem, like clouds, smoke, fog, and all low light conditions. That's our restriction.
Second is synthetic aperture radar or SAR. It gives you an ability to kind of see through clouds and smoke, but it is not as intuitive to human eyes.
Just like X-rays, right? It's not something that you directly feel. It's purely physics.
And you certainly need more experts to understand that imagery. The third is thermal, where you are looking through and observing thermal signatures.
It's okay to imagine because we are able to feel temperatures, we know what different objects look like, right? So we have an intuitive view of these things, although it's not visually interpretable. In an ideal world, we'd have optical, thermal, and radar coming in all together and taking each of its own advantages of feature, of visuals, of consistency, and bring them together. Right. At GalaxEye, I think we've taken one big step towards this in building 2 sensors together.
Both looking at the same place and capturing images at the same time. And then we'll fuse this image to make a sync-fused image. The potential it will unlock in the geospatial sector is something which we are very excited to see.
The fact that you have more information about the same place, you can get a lot more insight out of it. For example, you can maybe even build 3-dimensional models, right? You get a third dimension of the same area through SAR because there's an active sensor.
Having a SAR along with an optical can help you not only detect the camouflage but also interpret what's the material that is inside the camouflage. So because SAR is affected by the dielectric properties of the material, the image would really be affected by the kind of material which is present inside that camouflage.
Like as humans, one of our first images that we've seen has been black and white. Right? But when we saw color, we realized there's so much more we can do with colored imagery. And that's what we want to see happening, right? Have that moment where suddenly see people come up with applications that were unimaginable.